So as I was saying that yesterday we carried out from asset security, data security, and we started cryptography, and we saw that cryptography can affect only confidentiality and integrity. It cannot affect availability, right? We saw basic terms and we saw basic mathematical operations which are used in cryptography, and then we stopped at a place where we were supposed to start symmetric and asymmetric cryptography. So we are basically going to see modern cryptography techniques. Right. Now, the first technique that is used is something called symmetric key cryptography. Now, what is the key? Symmetric key cryptography. What is the key? What is the symbol of the key? And the key is the part which is the access control to the information. So, you had an information, right? You made it pass through a mathematical function, okay, and it gave you a encrypted value. But there was a key, there was a involvement of a key. This key was used to reach the place where you got the encrypted information. Now, this key is the only mathematical function or the mathematical value which can again help you in decrypting and getting the information back. So in a way, the key is the access control methodology to the information, to the encrypted information, right? Now, if this key gets into the hand of the unwanted person, what happens is your information gets leaked. That means the algorithm is the entire encryption process is no more reliable if you lose the key. That means if information you have encrypted using a certain key and you lose this key, you can take it for granted that information is no more classified or no more confidential. Why? Because you've lost the key and the key will be used to open this information. The only way now you can get rid of his information is by securely erasing this information before someone gets their hand onto this piece of information. Therefore, cryptographic keys are the most important part of the entire cryptographic process, and today the entire processes on the internet revolves around cryptographic keys, right? So first we will see what is symmetric key cryptography. Okay, what is symmetric key cryptography? It's very simple. Symmetric key cryptography is, you use you there's Alex want to send a message to Bob, right? So Alex and Bob are two famous characters of cryptographic concepts. Okay, so what happens is you have plain text. Okay, you pass it through a encryption algorithm. You pass it through algorithm, and you get something called a ciphertext. Okay, and you apply the key. Okay, now in symmetric key cryptography, Alex somehow has to send this key to Bob. Okay, so he has the ciphertext. He sends the ciphertext by email, right? Bob receives the email, which is encrypted, but now Bob doesn't have the key. How should you send the key? Should you send the key in the same email, okay, or through email? What will happen? If you send this key in email, this will lead to a process called in-band key transfer. That means you have passed the key and the message through a same tunnel. That means if somebody is able to intercept the email, will be able to intercept the key and will be able to open the email. That's why you never pass the key in the same band where you are passing the information from. That's the key concept of symmetric key cryptography. That means the key has to be passed out of band. And this concept is applicable to out of band. Out of band means you are not passing the information through the same medium or through the same band where you were passing the encrypted information. Right? Understood the concept? So that means once Bob receives the message, what happens at Bob's end is Bob receives the ciphertext and he receives the key out of band. He applies the key. Okay. He applies the key and the algo. The ciphertext is applied to the algo. The key is applied to the algo. And what you get back is the plain text. Right. This is the simplest process of having what is called as symmetric key cryptography. Now, symmetric key cryptography is the most common form of cryptography which we see in our, major in all applications which we use in the internet today. Right? Why? Symmetric key cryptography is fast. Okay, it's fast. It's though it's a complex process, but it is fast. Why? Because there are multiple steps involved, but it is in one stream. Okay, it is in one stream. The maths is such that it is faster in nature, right? Since it is faster in nature, you can use symmetric key cryptography almost at all places. But what is the major problem is how do you distribute this key out of band? Okay, this is one of the major problems. Second thing is, there is no way I will come to know whether the information has been changed. If somebody changes the information or this information gets corrupted, there's no way I'll be able to find out. Okay. Third thing is there is no way of implementing non-repudiation. Okay. Because everybody is having the same key, everybody is having same copy of the key. I don't know who has sent the message unless it is explicitly, mentioned outside the message. Inside the message, if it is there, I will not come to know who has sent me the message, right? And if you look at it, the moment you have more number of people who want to communicate with each other using symmetric key cryptography, the problem arises. Say there are 10 people who want to use symmetric key cryptography. That means A, B, C, D, E, F, G, H. Say there are individuals 1, 2, 3, 4, 5, 6, 7, 8. And each one of them wants to communicate securely with other. So how many keys are they going to require? 1 key, 2 key, 3 key, 4 key, 5 keys, 6 keys, 7 keys. 7 keys they are going to require for, with each user. Similarly, each user will require now, keys. So if you look at this, it comes to n into n minus 1 by 2. So if n here is equal to 8, the total number of keys that will be required are 8 minus 1 by 2. That is 7. 8 in the 56 by 2. That is equal to 28 keys. You will require, for 8 people, you will require 28 keys, independent keys, so that they can communicate with each other using symmetric key cryptography. Am I clear? Any doubts? So what are the most common, symmetric key algorithms? Those who have heard DES, AES, okay, skipjack, okay, blowfish. These are all symmetric key cryptography. Right. Now, next concept is, now look at this. If you had 8 people, you need 28 keys. That's a huge problem, right? How do you distribute this 28 keys to 8 people? Okay. And on the internet, when everybody is unknown. So the concept of asymmetric key cryptography was brought in. Now, the asymmetric key cryptography is also called public key cryptography. Okay, what happens is if there is Alex and Bob, they both have two sets of keys. Okay, it has Alex public key and Alex private key. Okay, and similarly, Bob has Bob's public key and Bob's private key. The private key remains private. The private key remains private with Bob. Similarly, Alex private key remains private with Alex. Okay, how does the encryption happen? The encryption happens is if Alex wants to send message to a Bob, what Alex does is he takes the plain text, puts it into the algorithm, applies, since he wants to encrypt it, right? He applies receiver's public key because Bob's public key is public. Everybody makes their public key public. So this is public key. This public key goes actually to a repository, to a PKI, public key infrastructure, where Bob's public key is there, Alex's public key is there, right? And you have to fetch that key. So Alex, once he wants to send message to Bob, Alex goes and fetches Bob's public key, encrypts this information using Bob's public key, right? What he gets is a ciphertext. Okay. Then he sends this ciphertext to the receiver, that is Bob. What Bob receives is a ciphertext, which he again puts through the same algorithm. But now he does not need his public key. He needs his private key, which is there with him. He applies his private key and he gets the plain text back. That means the information which is encrypted by Bob's public key can only be decrypted by Bob's private key only. These are the two key pairs. These are the two key pairs. And that's why it's called asymmetric key cryptography. Am I clear? Okay. Right. Now, the number of keys that are required between the same number of people, if there are 8 people who want to communicate, it is 2n. That is 2 into 8, which is equal to 16. You just need 16 amount of keys, right? Please repeat. Okay, Uday. No, not understood. Okay. Right. Alex wants to symmetric key, understood, Uday?
Yes, sir.
Okay. So symmetric key is one key. You have to distribute one key to everyone. They can use that key, right? Now, Alex and Bob, they both generate 2 keys. Okay. Alex public key and Alex private key. Similarly, Bob generates Bob's public key and Bob's private key. Clear? Step 1.
Right.
Okay. Now the private key remains, it's private, right? Name is private. So private means it remains private with Alex. Private key remains private with Bob. Okay. And the public key is given to a key repository, which is generally called the PKI, public key infrastructure. Now here, all the public keys are there. So Alex public key is here. Bob's public key is here. Right? Clear? Okay.
Right.
Up to clear up to this point? Okay.
Yes,
now Alex wants to send a encrypted message to Bob. So what Alex does is Alex wants to send a message. Okay, so this is the plain text. He puts it in the algorithm and gets Bob's public key from the repository. Alex requests that I want to send a message to Bob. Give me Bob's public key. Okay. So now Bob's public key is fetched by Alex, and Alex encrypts the message using Bob's public key. Whosoever you want to send the message, you get that key and encrypt it. And now you get the encryption message, right? And now you send the message using email, WhatsApp, whatever you want to send. Bob receives this message, right? Now he's got to decrypt it. What key can he use to decrypt it? Now, in asymmetric key cryptography, whenever you generate these two keys, these keys are, work in pairs. If you use one of the keys to encrypt, the other key will be used to decrypt. If you use this key to encrypt, then you will use the another key to decrypt. That is the relationship between these keys. That means the key has some kind of a relationship, okay, which is called prime number factorization, which we will discuss later. You just understand the process and then we will discuss. So you send the message. Now Bob receives the message. Bob doesn't have to do anything. Bob just needs to apply his private key to the encrypted message and to the algorithm. The encrypted message is sent, the key is applied, the private key is applied, and you get the plain text back. Right? You will say this is magic. No, this is not magic. This is maths, right? It's done by something called prime number factorization. Does it make it clear, Uday? Are you clear?
Yes, sir. Very much.
Okay. Now, say Bob wants to send a message to Alex. What will Bob do? Can you explain? Okay, so Bob wants to this is Bob. Okay, this is the algorithm, and this is the plain text. Okay, Bob wants to send an encrypted message to Alex. Now, what key is Bob is going to use to encrypt the message?
He will get public key of Alex.
He will take public key of Alex. Very right. Okay, he gets the encrypted key, right? And now he sends this message to Alex, right? Alex gets the encrypted key. He puts it in the algo, right? What key should now Alex apply?
His private key. Alex private key.
Alex private key, and he will get the plain text back. Clear? Everybody clear?
Yes, sir.
Yes,
Thank
yes,
you.
yes, yes.
Now, what does this? Does it prove confidence? Does it, does it affect confidentiality or integrity? It affects confidentiality, right? How both? Somebody said both. How does it affect integrity?
But nobody can change the, I mean, the data context cannot be changed.
Okay, say daughter. But how does Alex know that this message has been sent by Bob? Alex doesn't know. Bob can refuse. I have not sent you the message. That's non-repudiation, right?
Yes.
Okay. Integrity, how will you check? Unless you have the hash value. You don't know what was the message sent. What was the initial message? You don't know, right? Do you have any technique to find out that this is the message which was actually written by Bob? Do you have any ways of finding it out? You don't know.
Yes.
Right? You don't know. So there is a technique, okay? And that's called digital signature, and we will discuss later, okay? Understood this much? Now, what is the best part about asymmetric key cryptography? Okay, asymmetric key cryptography can prove both confidentiality and integrity. How? We will see. The concept of digital signature will come in. Now, the best part about asymmetric key cryptography is key distribution is very easy. You see, I just developed my own key. I put the public key to a third-party repository, trusted repository. And if you have used digital signatures, you get a dongle, which you keep with yourself. Your public key is in the repository. Okay. Key distribution process is very simple. Okay. But there is a problem. The process of encryption is slow. So that's why there is a edge between, the symmetric key cryptography has an edge because it can do encryption faster. And that's why whenever you have speed limitations, you use symmetric key cryptography. Okay. Now, once you look at this, how we can use, asymmetric key cryptography to prove integrity also. I will just show you. Okay. Now, let's take this a little slightly complex example. Okay. Bob wants to send a message to Alex. He wants to prove the confidentiality is there, and he also wants to prove the integrity of the message. That is, message has not changed from the time he has sent to the time it reaches Alex. Okay, this is the problem statement. What we will do is, Bob will take a message. Okay, he's taken the message, plain text. Okay, now Bob wants to send it to Alex. All right, so he needs first confidentiality. What will he do? He will use Alex's private key, right? And he will have the encrypted message. Are we all clear? Right? So we have the encryption. This is the first step.
Public key.
So we have, Alex's public key. I'm sorry. I'm so sorry. Alex's public key, right? Because he has access only to Alex's public key. Okay. Now to prove that he has sent the message. Okay. What can Bob do? Okay. Bob can carry out hashing of the plain text. He takes the plain text, passes through a hashing algorithm. So what does hashing algorithm do? It gives you a fixed length output. We saw that, right, yesterday? One-way function. So what he gets a fixed length output of the plain text. So he's taken the plain text, did a hashing, he got a hash. Okay. Now, once he got the hash, what he does is, he attaches the hash of the message. He attaches the plain text hash of the plain text with the message, right? And encrypts it with his private key. Not the message, only the hash. He's taken the hash and encrypted it with his private key. So now what happens? He's got the encrypted hash, okay, and the main encrypted message. Am I clear? Am I clear? Am I clear?
Yes, sir.
Step 1, he's encrypted the message. Step 2, he's taken the hash of the original message. Step 3, he has encrypted the hash with his private key. And now he has sent this as a package to Alex. So what happens as Alex sends? Gets two things. He gets the encrypted message and he also gets the encrypted hash. He keeps the hash aside. He takes the message, applies his private key, and he gets the plain text back, right? But he still doesn't trust the plain text. What he does, he takes the plain text and hashes it with the same algorithm which was used here, right? He hashes it and he gets the hash of the message. He also takes the encrypted hash which has come with Bob's private key, uses Bob's public key. What he gets is the original hash. And then he compares this. If these two are fine, what does it prove? It proves two things. First is the message integrity is intact. And second thing is that Bob sent this message. Clear? Integrity, confidentiality, non-reputation. All three are proven in this process. This is the exact process how we do digital signatures. Any doubts, guys? Please ask again. this should be ingrained inside your head for CISSP exam.
Yeah, right. Very much clear, sir.
Clear? Please practice it once. It will get inside your head. Okay, I have covered everything in cryptography. This is all you need to know. You need to know symmetric, you need to know asymmetric, you need to know digital signature. Okay, now since asymmetric key cryptography is slower and symmetric key cryptography is faster, I use something called hybrid cryptography. What do? Two people, unknown people, want to communicate on the net. I establish a secure tunnel using asymmetric key cryptography. Then I pass the symmetric key cryptography inside this session. This is called a session key. Okay. And I use the symmetric key for the session. Once the session drops, I have to again use asymmetric key cryptography to establish a session. Such arrangements, whenever you are using a VPN or using HTTPS, this is what is happening on the web. How it happens is, in this case, you are not your public keys. You have a browser. Okay, you open Google Chrome, right? Chrome associated with your desktop has two keys, a public key and a private key. It sends the public key to the PKI. Whenever you're installing Chrome, the first time, this key exchange takes place using a secure IPsec process, and your public key is stored with the PKI, and your private key is stored inside the TPM module, inside your laptop. Okay. Earlier days, this private key would be stored in a mathematical function somewhere in your hard disk, but these days it is stored in your TPM, right? And now once you want to access some website, okay, you send a request, the web server picks up your public key, okay, and creates a session between you, passes a symmetric key, okay, and then maintains this session using a symmetric key. We will see it further how it is done, right? So this is the process of hybrid key cryptography. Okay, clear? Any doubts? Please. Okay, if none, then let's go forward. If anyone has any doubts, please, guys, please be free to ask. I know that not everyone has done everything. So
Yeah, that is. Can we discuss one more time on the hybrid?
Hybrid. I'll take on hybrid. Don't worry. I'll take on hybrid. Okay. Let me go ahead. I will take on hybrid one more time once we go to different standards. Okay.
Is it only going to be like in initiating during session initiation only you are using
Yes.
this?
Yes.
That's only the difference.
Yes. You have to initiate the session. Now, to initiate the session, you do not have a symmetric key, right? You want to pass a message very fast, but you don't have a symmetric key. You want to exchange a symmetric key, but the only thing you have is your public key and private key, right? A public key and a private key. So what you do is you take the public key, okay, and the private key and mix it. We'll see Diffie-Hellman key exchange, okay, and then you match it and create a key, and then you pass this key. And once you have passed this key using the session, this is used as the session key for that particular session. Okay, it is at the beginning of the. That's why if you any HTTPS site, if you go it for the first time, there is an initial handshake of these keys which happen. Okay, and the symmetric key, the session is generated, and the session key is passed, and then you do on a secure mode using the symmetric key cryptography. Okay. Now, how do developers implement that? There are libraries in the programming languages which help them implement these operations. Okay. Okay.
So
Now,
what about like when you have established session, and what was the need of having asymmetric is to prove other two factors like non-repudiation and the integrity. So once you have established session, how do you, if a session gets hijacked? So
oh, session gets hijacked. Session hijacking takes place. Okay, once you have stored the session key inside a cookie, and this cookie gets exposed. The hacker takes over this cookie. Now he has your session key, and then he plays this key repeatedly to the server, and the server is not configured properly. What happens is a replay attack. And that's why you say you should always close down your browser sessions, because if a hacker gets the cookie has a certain life, your session key is inside this cookie. Okay. And this cookie, if the hacker gets it, then he takes this key and replays it to the server. And if the server is not configured properly, the web server is not configured properly, server will give entry to the hacker. That is how exactly session hijacking takes place. There are browser vulnerabilities which can expose these cookies to the hackers, right? Or there are malwares who have infected your browser and steal the session cookies and give it to the hackers command and control. Then the command and control hackers, then they use your key to ask the server for a session. If your server has not been configured properly, it will give the session. And such sites are vulnerable to replay attacks. Clear? And that's how session hijacking takes place. And that's why they say, please shut down your browser. Why? The moment you shut down your browser, the cookie is destroyed. You basically get rid of the session key. Always log out. The moment you log out, the session key is destroyed.
even it is applicable in banking apps, what you log in and once you have start a session with the applications.
No, but what happens in banking is banks automatically log you after 5 minutes, right? If there is 5 minute inactivity, banks automatically log you out. Why?
Mm-hmm.
Simple, right? So when in the apps also, when you log in, there's a session created, right?
Okay.
Clear?
Yes.
So the process which I explained was called, digital signature. Okay. So today's part of my explaining with, backboarding is over. I will now go with the slides today, because rest all is something which I can explain on the slides. There's something which I've already explained yesterday, right? Okay. Okay. Let's have a question. Brute forcing means the entire key space. And if it is an 8-bit system, it is 2 raised to the power 8 is going to be the entire key space, which is equal to 256, right? Okay, we saw all this functions yesterday. Okay. Okay, another question. I did not discuss one-time pad yesterday, but I made a mention, if you guys remember. I made a mention that there is understanding between two people. Okay. Or can someone tell what is a one-time pad? Anyone? Okay, one-time pad is a cryptography. It's not cryptography actually. It's a coding technique. One-time pad is when two people decide, A and B decide, they make a book, okay, and they have certain characters deploy, each character meaning something only for one-time use. If between me and you, we have an understanding that X is a dog, okay, Y is a pen, Z is a okay color, and I want to convey that you know that a dog is carrying a pen of white color, right? So that means I will write X is carrying a Y of Z color, right? Now this is one time I passed you, you got this message. Now next time when I'm going to send you a message, I'm not going to use this code. Next time my X will be 2 raised to the power 7, Y will be 74, Z will be some hexadecimal ABX. Now you see the randomness, right? Next time I send you the same message, you know X is something. So you see the randomness, right? That means one-time pads, if are used very, very in a complex manner, you will not be able to break those codes. But the moment you start repeating, okay, like when we used to, operate in Northeast, and the militants used to use, when they used to see army guys, okay, they used to pass on the radio sets. There was a Sikh battalion, Punjab battalion was there, so they would pass, "Lambe baal wala aa gaya hai," okay. So that means they are saying that Sikh regiment guys are there in your area, so operate carefully. So over a period of time, we came to know their code words because they were not repeat. They were repeating the code words. If they have planted a bomb somewhere, they were using "nariyal laga diya hai maine." That means I have put the bomb somewhere, right? We were getting such inputs, but they were using the term "nariyal" every time. We know that it's a bomb, right? So one-time pads are the most secure form of encryption if the pad is highly complex, highly random, and it is non-guessable, and it is used only once. The moment you use that logic, you destroy it. It basically is unbreakable, right? And that's why this question, in this particular question, all of the above are, is the right answer. And I had not exactly taken one-time pads yesterday. So one-time pads are the most secure form of encryption. Right. Okay. So modern cryptography, I have told symmetric key, I have told you public key cryptography, I have told you how hashing works. Okay. Let's have a small question on hashing. You will get such questions. Huh? CISSP is very fond of such questions. Alex and Bob questions. So here we are only trying to check non-repudiation, right? And non-repudiation can be checked by both digital signature, okay, and public key cryptography, right? Most of you have guessed this correctly. Right. Let's take a short break and then we will explore the algorithms which are used in both public symmetric key and asymmetric key cryptography. If you have any questions, please ask. Any doubt?
Can we go to the
clarify?
previous question? Previous
Yeah.
question. Anyway, I
Yeah.
also gave the C only, but why cannot D, symmetric key cryptography and digital?
Symmetric key cryptography will not be able to actually, wherever digital signatures are there, all three are acceptable. But what I'm trying to say is, Bob is worried that Alex might refuse. Refuse means non-repudiation. Non-repudiation means I need to use digital signature, right? Now, generally, you do not use symmetric key cryptography with digital signatures, okay? Because how will you decrypt it, right? You will not be able to decrypt it. Where is the key? Okay, so you might use the symmetric key cryptography, but how will you prove? Because you will not be able to send. You have to send also, right?
Yes.
So you cannot prove. So public key cryptography will help you in encrypting it and sending it. Okay, that's why digital signatures and public key cryptography will help you in establishing refusal, right? But if you look at random.
Thank you for watching. Don't forget to subscribe our channel.